Okay. So sometimes you get a question of this kind. Suppose there is a prism of this kind. This is a right prism, right isosceles prism. So this is 90, this is 45, and this is 45. If a ray of light is incident perpendicular to this, okay, if a ray of light is incident perpendicular to this, understand that it will not undergo any refraction. Why will it not undergo any refraction? Because this rays which are incident normally, sign of angle of incidence is 0. Because angle of incidence is 0, it will not undergo any refraction. Now suppose this is made up of glass, and a glass is having refractive index of 3/2. We already said that the critical angle is for approximately 42 degrees. So now what will happen is, this angle is 90, this is 45, so this is also 45, so this angle will be 45. Now if this is 45, this angle cannot be refracted, it will get reflected, and it will get reflected, and after reflection it will go and hit this surface, okay, such that this angle is 45. Now this is 45, this is also 45, this is 45, so this is 90, so this angle here must be 90. So in fact this is going to come and hit straight, and when it hits straight again, angle of incidence is 0, so it can emerge this side. So now this ray was going this side, ultimately it landed up going this side, so it has got deviated by an angle of 90 degrees, right? So here this ray got deviated by 90 degrees. Now there are two extremes that you can have. In the last question that we did, we said there was a ray which was at grazing incidence, so the ray went this way. The extreme you could have is the other one, where the ray is incident normally. So this is grazing incidence, this is incident normally. Okay. Now sometimes what they do is they complicate these questions by telling you that there are 3 different rays. Okay. What we have not discussed so far is that the refractive index mu, we said mu is a constant. Actually mu is a constant for a given color. For a given color, mu is constant. If the color changes, mu also changes. That means if mu increases, you will see that, if lambda increases, mu decreases. If lambda decreases, mu increases. That is, mu is inversely proportional to lambda. Mu is inversely proportional to lambda. Because it is inversely proportional, we will say 1 upon lambda. Which means that if I look at Vibgyor, violet has minimum lambda, hence it will have, violet has minimum lambda, hence it will have maximum mu. Similarly red has maximum lambda, hence it will have minimum mu. Okay. So now as you move from violet to red, the refractive index decreases, the refractive index decreases. As you move from violet to red, refractive index decreases, the wavelength increases. So we should remember that wavelength is inversely proportional to mu. So what happens is, because different colored lights have different refractive index, what will happen is each one of them will undergo a different deviation. So the moment light hits this, each color will undergo different deviation, and you will have red light which deviates least and violet deviates most, because the refractive index for violet is maximum mu. Because of maximum mu, violet is going to deviate the most. So when violet deviates the most, when it emerges out, it further deviates. And what you see on the screen, suppose you have white light here, you see Vibgyor on this side. That means dispersion has taken place. And you will see Vibgyor on this side. Okay, and remember, dispersion takes place here. So why does dispersion take place? Dispersion takes place because light of different color have different wavelength and hence different mu's. Then mu is inversely proportional to wavelength. So just remember this. Okay, so this is the reason why dispersion takes place.